Welcome back. I am Charlene and today we are discussing Newton's first law of motion. Before the break we were left wondering why passengers have a tendency to lean back as their bus starts suddenly. Full points for having guessed inertia of rest as the culprit. This is because when a bus starts suddenly, the lower part of the body moves forward with the speed of the bus, but the upper part of the body, due to inertia of rest, tends to remain at rest. Hence the upper part is left behind and the passengers fell backwards. Now let me show you something. This coin could buy me a candy. This coin can decide fates on a cricket pitch in a cricket match. And if it had two heads, it could have been used by Amitabh Bachchan in Sholay. But right now, it will demonstrate inertia to you. Let me place it on a card over a cup. There are two forces acting on this coin right now. The earth that is pulling the coin downwards and this card that is pushing it upwards. These two forces balance out each other and therefore the coin is at rest. Now if I apply a horizontal force on the card, it will accelerate and move away, and since the friction between the card and the coin is negligible, there will be no force on the coin in the horizontal direction. It will remain in its original position due to inertia of rest. Now watch. Did you see what happened? When the card moved away, the coin fell into the glass because it preferred to maintain its state of rest due to inertia. So it was the coin's inertia that made it stay in one place. The force was on the card and it moved away. The force was not placed on the coin itself. In other words, we can say only a force can change an object's state of rest or its state of motion. The next thing to wonder is inertia in any way influenced by the mass of the body? Let's say that we take a football and kick it as hard as we can. Wow, that sure went a long way. Now let's try kicking a stone of the same size, but obviously of a heavier mass. Oops, that may hardly even roll. This clearly means that the heavy stone resisted the attempt to change its state more effectively than the football, which shows that the stone has larger inertia of rest. Therefore, we can say that a heavier body has greater inertia than a lighter body. And this is true for inertia of rest as well as inertia of motion. Let's take another example to understand this even better. Consider two bodies, one of mass 5 kilograms and the other of mass half a kg, that's 500 grams, moving towards you with equal velocities. When you try to stop them with your hands, you will realize that the lighter comes to rest while the heavier may only slow down a bit. Therefore, larger the mass, larger the inertia, and smaller the mass, smaller the inertia, which means that mass is basically a measure of inertia. I'm sure by now most of you must have already figured out why we are pushed forward when a running car stops suddenly. It's pretty much the same thing what happens on a stationary bus. Let's see again what happened when I tested the brakes of my car. One thing I remember whenever I'm driving at this kind of a breakneck speed, my brakes. But why does this braking always push us forward? While the car was running, my body's speed was equal to the speed of the car. As the car stopped suddenly, the lower part of my body, which was in contact with the car, came to rest. but the upper part of my body, due to inertia of motion, remained in the state of motion, and therefore I was pushed forward. Before moving on to solving some problems and answering some easy questions, let's summarize what we've gathered so far to make sure we are headed in the right direction. Number 1. Newton's first law of motion states that a body at rest will remain at rest and a body in motion will remain in motion unless acted upon by an unbalanced force. Number 2. The property by the virtue of which an object tends to remain in the state of rest or of uniform motion unless acted upon by some force is called inertia. Number 3. The mass of a body is a measure of inertia. That was just the gist. For more on your syllabus, concept tests, quiz questions and exam tips, log on to topperlearning.com. Time now to answer some questions that some of you have asked. The first one is,
state Newton's first law of motion.
a body continues to be in a state of rest or of uniform motion along a straight line unless external forces act upon it. Let's see the next one that was posted on our website topperlearning.com. Define inertia and what are the two forms of inertia. Now, the inability of a body to change its state of rest or of uniform motion on its own is known inertia. All bodies have the tendency to resist the external agency trying to change their state of rest or uniform motion. Inertia may be thought of as having two forms: inertia of rest, due to which a body remains at rest, and inertia of motion, due to which a moving body keeps moving without any change in its velocity. The next question is,
why does a fan continue to move for some time even after it has been switched off?
oh, that's simple. A fan has a tendency to continue its circular motion even after it is switched off due to the inertia of motion. And now I have a question for you. Why it is dangerous to jump out of a moving bus or a moving train, and how can this danger be minimized? It's only okay in Hindi masala movies to toy with dangerous ideas such as jumping out of moving trains. But nevertheless, while you think of how to minimize the danger for the stuntman, I'll take a short break. Coming up are some interesting exam tips. I'll be back in a jiffy. Don't go anywhere.